Hey, in this video I'll demonstrate how to use YugabyteDB Voyager to perform a live migration from Oracle database to YugabyteDB. Let's get right into it. You might be familiar with YugabyteDB Voyager's offline migration process. This process involves exporting a schema from the source database, analyzing and modifying this schema in case you want to make any changes to the recommended schema, and you can export the data from the source as well. Then this schema is imported, data is imported, and so forth, all handled offline, and then you can cut over your applications manually. The live migration process is a bit different in that changes that are occurring on the source database are constantly being watched and written to an event queue on disk. These changes are then automatically written to YugabyteDB so that when the cutover takes place, your application downtime is extremely minimal. Let's see how this works. So let's say we have a user application pointing to a source database, in this case, Oracle database. We can export the schema from this database as well as the data. When the data is exported, first, a snapshot of the data is recorded and stored in the export directory. Then any additional data that's being written as the application continues to process writes, all of this data is added to an event queue so that it can continuously be imported to YugabyteDB. And only when this event queue and all of the imports have caught up to those being written to the source database, does your application actually cut over to using YugabyteDB and continue processing writes on YugabyteDB. So that's the main difference in using the live migration pattern, is this cutover phase and the live migration phase, that writes are continuously being monitored, added to a queue, and a cutover can be initiated all online as opposed to offline. So let's walk through an application that's running on Oracle database and go through the whole process to cut over to using YugabyteDB. The application that I'm going to migrate from Oracle database to YugabyteDB is called Yuga Rentals. This application works on both Oracle and YugabyteDB and is based on the popular Sakila schema. This schema is for a DVD rental store, which might be a bit of a blast from the past. Some of our viewers might not even know what a DVD rental store is. This is a very old schema that was originally developed for MySQL and has since been ported to Oracle, Postgres, and many other databases. This application in real time is showing recent rentals in the rental store, as well as sales by film category. Let's check out the schema. So as I mentioned, this schema has been ported over to work on a variety of databases. Here is the schema information. So this database includes a lot of different tables, films, customers, rentals, and so forth. It also has stored procedures, triggers, and numerous other facets of Oracle database that will need to be ported over to Postgres. So we can make sure to walk through all of those language features and make sure that we are able to successfully migrate over to Postgres and YugabyteDB. So let's get into the application and work through a full migration end to end. To begin our migration, we first need to install Voyager, which I've done on my machine using Docker. We also need to prepare our databases. I have an Oracle instance running in Amazon RDS, and I've created a new user with the access required to read and migrate our data. For Yugabyte, I'm using YugabyteD for our database, and I've prepared this database as well by creating a user with the necessary privileges. By using YugabyteD, we also get some new UI features for migration, which will help us, and I'll walk through that shortly. So before we export our schema, I'd first like to review it. Our schema has various tables. We can see we have an actor table, which makes use of a sequence and a trigger. We have various other tables, triggers, sequences, as well as views down here at the bottom of this file. So all of these dialect-specific features will be migrated over to YugabyteDB. Now let's verify that this schema and data is actually seated in Amazon RDS for Oracle. I have an Oracle client shell open, and we can just do a very simple verification before we actually export and analyze our schema. We can select the user tables, actually. Table name from user tables. We can see we have 16 tables. Now let's actually verify that we have records in some of these tables. We can count the number of films. And we have 1,000 films in our database. Good enough for me for a rough test of our schema. Now let's actually export our schema. Before migrating our schema, it's helpful to generate a migration assessment report. This report will analyze the source database to determine the feasibility of a migration. It'll analyze the schema and recommend cluster sizes and various performance metrics on the source database. This will be helpful for setting up the database on the YugabyteDB end before migrating. So let's go ahead and do this. It's also nice to generate a migration assessment while the application is running. This will analyze the database in a representative state rather than analyzing a database that is currently not in use. So I'm going to cut over to the UI of our application, and I'm going to begin to simulate a bunch of writes on our Oracle instance. And as we'll see, rentals are being generated, and we have the database running. Our YugabyteDB instance is running with YugabyteD, and the migrations UI is available, but no migrations are currently being run. So moving over to the terminal, I'm going to generate an assessment report. And this report will begin analyzing our schema and collecting all of the necessary data to create a report. This step will take a little bit of time, so I'll fast forward the recording and then we can analyze the assessment report. After about a minute or two, the migration assessment has completed successfully and has been output to the export directory that I've specified in the CLI command. This report comes in both JSON and HTML formats. This is also available in the YugabyteD UI. However, this feature is currently in technical preview, so this hasn't been fully implemented. It's more so available for offline migrations. However, a lot of the functionality is available and is worth checking out at the time of recording. So let's go over to the UI and see how this looks. We can see that a migration has been populated down here in the Migrations tab, and it's currently in progress. The assessment has completed and recommends an instance type with 4 virtual CPUs and 16 gigabytes of memory. A 3-node cluster is recommended, and you can see some information about the schema recommendations, and it looks like all of our DDL statements will be able to be imported without any manual refactoring. Later on in this process, we'll actually be doing a schema assessment to make sure that the analysis of the schema returns cleanly and all of this is in fact valid. So let's move forward with exporting our schema now. Now let's export our schema to our export directory. We can see that this has initiated and it'll just complete in a bit of time, so I will be right back. Our export has successfully completed, and as I mentioned previously, all of the dialect-specific features from Oracle have been exported and will then be ported over to YugabyteDB. Now we can analyze our schema that's been exported using the analyze schema command in the CLI. I've specified that I want the output format to be text. We'll also be able to view this in the Yugabyte UI as we did previously with the migration assessment. So as we've seen before, this has been exported to our export directory, and we can check this out in the UI as well. We can see in the schema migration tab of our migration UI that export and analysis has completed. We have various valid SQL objects, as I mentioned previously when we went over the schema. But we do have some suggestions and errors. We are seeing that some SQL syntax is not able to match Postgres syntax from Oracle to Postgres. And we have an issue with the bulk collect keyword of Oracle. Some GitHub issues are actually linked within this, which is really nice to be able to track certain issues that are being worked on by the YugabyteDB Voyager team. And we can see this specific issue that might need to be rectified before handling the import of our schema. So this is a nicety. This migration process is not a zero-touch migration. There are some spots where we will need to rectify these errors or just take the recommendations of the tool to mitigate some issues down the line with our migration. So let's go ahead and edit the schema as necessary. So the errors being reported from the schema analysis were in the package.sql file. Here I've opened up the export directory and navigated to this file, and we can see the various functions and schema changes that are included in it. Now, it doesn't appear that any of these functions pertain to the UI and the application that I've developed. So like any self-respecting engineer, I'm just going to delete all of this code from the schema. Of course, in a production deployment being migrated, these functions could be changed such that the syntax is compatible with Postgres and thus YugabyteDB. But to move us forward, let's delete the contents of this file, and we can head over to our terminal, and let's actually initiate the import of our schema. A bunch of types are created, sequences, tables, and changes to these tables are being made as well. So it looks like everything is being created as we'd expect. This doesn't take a long time, but we will find that we will have an error at the end of this schema import to YugabyteDB that was not caught on the schema analysis. There are still some gaps in the tool's understanding of the schema. It's very unlikely that everything will be caught during a migration, but this tool is being actively developed and it's being improved rapidly to the point that there are very, very few moments where intervention is necessary during the migration process. So as we can see, we do have a file that's exported, failed.sql. So why don't we open up that file and see what needs to be changed. everything else imported as we'd expect. So let's see if we need to make a change after that failed import. Heading back over to our export directory, let's look for fail.sql. So we see that one of the views that was imported had a mismatch. It looks like a character was expected in our view, but an integer was provided. So here we are actually expecting a string instead of this integer. So this can be updated to a Y. An active customer is denoted by yes or no. So this should be a Y. And we can head over and we can actually go to our Yugabyte shell. I've connected using the YSQL sh command line utility. And we can update this. So I've actually created this view manually by determining what was failed, or I guess the tool told me what failed during the migration. So this just shows another way that these issues that you might come across during a live migration can be rectified. So now that we've migrated our schema from Oracle to Yugabyte, let's go ahead and execute a live migration. Let's begin by exporting data from our Oracle instance, first as a snapshot, and then continuously as changes are being made on that instance. So we can specify that we are exporting data from source, and we're going to do snapshot and changes as the export type. Our application is running with writes being simulated on this database. And we can see that first a snapshot is going to be sent to our export directory. And then additional changes are going to be captured and added to a queue. We see that the following columns are unsupported. So YugabyteDB is not compatible with clob or blob data types. So these are going to need to be changed in order to migrate successfully. For now, we can just ignore these. And now we will work through the process to export all of the data from this database. This might take a moment. As we can see here in the terminal output, a snapshot has been created with the number of rows for each respective column. Now we also have export events. So writes are being made to this Oracle instance with new rentals being made. And we have over 200, which will need to be drained from the queue and imported into YugabyteDB using the import utility from YugabyteDB Voyager. Let's execute this import now. To illustrate a live import of data, I've split our pane in our terminal to show the export of data running in the top pane. And now we can import data on our target database on the bottom pane. So as we're running our import, what we're waiting for is for this script to capture all of the changes in real time from our queue. And we need this queue to be drained such that it's caught up to the changes on our source database. Once this has been fully caught up, then we are able to cut over our application from pointing to Oracle to pointing to YugabyteDB. And then we can complete this process. Here we can see that because writes are relatively slow on our source database, we've almost immediately caught up, and we are now able to cut over and point our application to YugabyteDB. Now that our imports to YugabyteDB have caught up to our exports from Oracle, we can initiate a cutover, starting by stopping writes to our source database. So I've stopped the application so no writes are being made to Oracle. And now we can cut over. Cutting over will stop the export process as well as complete the import process to Yugabyte. Then we can change our application to point to Yugabyte and continue processing writes to Yugabyte instead of the original source database. Then we'll be all finished. So let's initiate a cutover to our target database. There is also a command for checking the status of our cutover. Let's see what is being said here. Export data is complete here for export events, and import data is complete as well. So now we can go ahead and update the environment variables, which hold our database connection details, and we can complete the full migration and cutover to YugabyteDB. I've verified that the cutover has completed by using the cutover status command, and I've done a sanity test of our YugabyteDB instance to make sure that all of the data has migrated successfully. So now we can go ahead and point our application to this YugabyteDB instance. Currently our application is down, so once the cutover has completed, it's time to go into our application and actually change the environment variables here to point to the correct instance. Now by just saving a file, we can see that we are changing from connecting to Oracle to connecting to YugabyteDB in our application. And we can go to our application UI and we can refresh the page. And we see that the very same values have been populated because our migration has completed and we have the exact same data on both instances. Now we can simulate writes to our YugabyteDB instance and see that they are populated successfully, thus ending our migration. So we only have one step left, and that is to clean up our export directory by using one additional command in YugabyteDB Voyager. To officially complete this process, we can run the end migration command of YB Voyager, which allows us to back up log files, schema files, data files, as well as our migration reports. We can store all of this data to a backup directory of our choosing. This process also deletes any metadata from both our source and target databases that are pertaining to the migration process. So I've already handled this on my end, but I wanted to show you I've only chosen to output log files, but we can check out my backup directory. And by checking out the logs directory, we can see that we now have logs for every part of the migration process, including our live data migration. So that's all it takes to execute a live migration from Oracle to YugabyteDB. If you have any additional questions, you can be sure to post them in our community Slack. And be sure to check us out on GitHub and give us a star. Thanks a lot. Have a good one.